Welcome to our weekly call, which is now being recorded, as you would have heard on your devices. I'll just share my screen momentarily, just to remind you all of the agenda. So hopefully you can see that. So the agenda for today, the bulk of the call, we're going to focus on a presentation by Geoff Huston, who many of you will know is the chief scientist at APNIC. Geoff will sort of take us through some of the highlights from a paper that was published on the APNIC blog I think a couple of weeks or so ago, the path to Resolverless DNS. And then, as per normal, I just highlight some recent developments, just in case you haven't seen those yet, to draw this to your attention. We'll talk about some forthcoming events, of which there are very many this week. Actually, it seems to be a very popular week for events, and I remind you of some forthcoming cool topics, and time permitting, cover anything else that anyone wants to bring up whilst we're on the call. So without further ado, let me stop sharing. So thank you again, Geoff, for agreeing to join us at such an unearthly hour in Canberra. I assume you're calling from home. Yep,
I am.
So I saw the paper that when it was published on the site, and thought it was an interesting subject. So it was well worth sort of sharing. But rather than just people reading through it, I think it benefits from having your additional insight and the chance to ask questions as well, which is, I think, always a bonus. So you should be able to share your screen, because I'm very well aware that your style is generally fairly slide rich, and over to you, and look forward to the presentation.
Thanks, Andrew, and well, for the rest of you, it's good afternoon and good evening. Look, it's a pleasure to join you on the call today. This is, I suppose, a topic that, as I walk through it, it's going to be familiar to most of you, so I will go through a lot of it relatively quickly, but in some ways, the implications of this are the bits that I find the most interesting. And it's the implications that I really want to dwell on a fair deal, and sort of think about how and why the DNS is changing, and what that implies. So, you know, this is the classic, you know, this is the DNS as we know about it. Yeah, and you all know this, you know, as stubs talk to recursives. Recursives are basically where caching happens. When you have a cache miss, you send off queries to authoritatives. And, you know, the general roles are stub resolvers are hidden inside clients. In fact, normally they're hidden in two places. They're right inside the host as a DNS resolver library, and often they're inside the CPE, the customer premises equipment, where you actually go through a forwarder or some other kind of relay, which again might have a rudimentary cache. But that stuff is sort of sitting inside the client network. The recursive resolver is normally the thing that is funded by what you pay your ISP. So the path to the recursive resolver is normally under the control of the ISP itself, and is sitting in the same sort of routing unit, autonomous system as you. And so it's not quite the public internet. And in theory, it's as private as your ISP lets it, which may or may not be very private at all. But of course, authoritative servers are everywhere, and authoritative servers are promiscuous answerers. Their job is to answer anyone or anything, and typically that's across the big bad internet to get there, because literally they are anywhere. So that's the typical architecture. What are the problems with this? Well, there's been a lot of work over the last 10 years to make the internet exceptionally fast, and of course what we've got to with content distribution networks is to collapse that distance right down into most of your traffic comes from your local data center. It's only things like Zoom where you actually notice delay once more, because everything else is kind of served locally. Now, the DNS can't do that easily. And once you start doing cache missing, the DNS can be astonishingly slow. Now, you might notice it a little bit, but it depends on the kinds of names and where the servers are located. In Australia, of course, it's quite obvious sometimes where you get this kind of pause while the DNS heads around the world to actually ask the authoritative servers that exist elsewhere. Now, a lot of cases we've been farming authoritative servers into also content distribution networks, things like the equivalent Route 53 and so on, which try and smear that DNS information around the world. But even with that, the DNS is slow. The next thing that you're probably aware of is, of course, that most countries, some quite renowned like China, some less so, but almost every single country has a list of naughty names that shouldn't be resolved. And the DNS is a really convenient point of control for this. And so filtering happens literally all the time. And of course, this is one of the few places where the consumer pops their head above the parapet sometimes to ask the question. And so if you really want to know what users are doing, look at the DNS, because it's one of the best windows on behavior that we know of. And of course, this kind of metadata collection can be done directly by the recursive resolver. And indeed, it was the vogue at some point for ISPs to sell their logs either raw or relatively anonymized. But of course, in some countries, including mine, that's contrary to the regulatory requirements and can't do it. So it happens at various levels. Or there are folk who simply try and sort of glom between the stub resolver and the recursive and look at the traffic as it flies by and collect the metadata that way. And last but not least, of course, people have been tampering with the DNS for decades. And one of the classics is to actually substitute an answer for NX domain. When there's no such domain, well, let's make a domain for it. And this is a screenshot from an Australian ISP. I used to work for them, where every time there was an NX domain, bang, up came this page because it wasn't NX domain. It was actually a redirection. They gave you the DNS answer to their own particular navigation page as a value add. You also notice, by the way, and you might remember this because it was some time ago, the browsers used to have two input fields, URLs for navigation and the Google search bar or whatever the search bar was, which were separate. That was a problem. Users got very confused and were typing search terms into one when they should have been the other and blah, blah, blah. And the odd sort of result was there was a huge amount of cross leakage between DNS and search. And they also observed that Google was making a lot of money indirectly from search. They were able to take that search term and monetize it. And so they thought, well, if Google can do it, we can too. And certainly various resolver operators, be they ISP or others, saw this opportunity to actually change the DNS and to turn NX domain into a money stream. Google, of course, were deeply offended by this. This was treading on, the core product of Google, of which everything else hung off. And so their investment in a large-scale open DNS resolver was an obvious answer, considering their capabilities even at the time. And their one undertaking, well, there are probably two, but their one was, it never lies. It just never lies. They were one of the early adopters of DNSSEC validation to back this up. But, the major principle was, if it's in the DNS, we will give you that answer. No filtering, nothing. If it's NX domain, it really is NX domain. And so that service gathered a huge amount of momentum, particularly in the enterprise sector. But of course, that has implications on the architecture of the DNS, because now between the stub and the recursive is this massive hop across the internet, because that open DNS resolver, whether it's operated by Google or Cloudflare or Quad9, et cetera, or, is not within the realm of your ISP and is quite readily observable. And so now a DNS system architecture has these kind of two hops across the open internet. Now you go, oh, well, it's just for the marginal number of users who use things like the open DNS resolvers, except that isn't a marginal number of users. We've done ad-based measurements now for many, many years. And we did one measurement exercise, which is ongoing. You can see it at that URL, where we measure the number of users by percentage across the world who direct their DNS queries through Google's public DNS resolver. Now, in this particular measurement, I'm actually looking at the users who could. So what we do is no matter what you ask for, the answers serve fail, so that I hop through all of the recursive resolvers that are in your etceteraresolve.conf, and 1/4 of users, either directly or through their ISP, or oddly enough, through their enterprise network, actually have Google somewhere on that list. So, you know, the big number, 68%, which is slowly going down over time, direct their DNS queries to their ISP operator resolver. Around 20%, the queries stay in country, and the other massive pool of users is 25% that can direct their queries to Google. So Google has captured a huge amount of market share across the internet. Massive. No other open resolver is like it. And those two at the bottom, the next biggest ones are Cloudflare and a Chinese one. There are an awful lot of Chinese people. They tend to weigh every single statistic. But you know, the problem with that hop across the internet was unencrypted UDP is a hop across the internet, which is massive. It's a huge DOS issue, but also it's a huge leak. And, you know, this whole third-party monitoring, eavesdropping, interception, substitution went wild because it could, you know, open traffic. Anyone can look. And of course, the CDNs had problems, particularly Akamai, which had a huge amount of emphasis on assuming that you and your recursive resolver were very, very close. And so if they geolocated the IP address of where the query is coming from, they would send you a content answer based on your DNS. So if you were whizzing around the world to use an open DNS resolver, your content was definitely suboptimal. So, you know, we went down the track with a little bit of prompting from the Snowden papers to actually say, look, this is not going to work very well. We're going to have to do something about privacy. And so, as all of you, I think, are aware, and certainly this session of meetings has looked at this in some detail, we've decided to attack the DNS unencrypted problem and turn it into encrypted transport sessions. And of course, after a little bit of mucking around with DTLS, which is a UDP version of TLS, which I think is still largely unimplemented, DNS over TLS, you know, which is straight up DNS over TCP with a persistent TLS, is gathering a fair deal of steam. Android took it up in its private DNS as an operating platform, and that's been a considerable impetus to this, I believe, although it does require users playing with the buttons, and users are never good at playing with the buttons, as we're seeing in the data. There's been a more recent RFC, it's in the 9000 series, and I've completely forgotten which one, which is DNS over QUIC, which is instead of TCP plus TLS, QUIC kind of bundles this, and it comes out over UDP, but everything, including the entire control system for QUIC, is inside the encryption envelope. And finally, of course, there's DNS over HTTPS, which uses both HTTP3, which is DNS over HTTPS over QUIC, or DNS over HTTP2, which is conventional TLS. And it prefers to use QUIC when it's possible. So all of these things have some common properties. Who am I talking to can be resolved in that TLS handshake or in the initial QUIC handshake, because effectively the other end presents some credentials which you're going to use in order to set up session keys. And so if you're trying to mimic 8.8.8.8, you've got a problem, because it's very, very hard to present credentials which are Google's. You don't know them. And so in some ways, this whole thing, and it was rumored that Turkey, when there was a fair deal of sort of use around some Turkish DNS blocks to use 8.8.8.8, there were some stories floating around that some of the Turkish ISPs simply set up a DNS resolver on that address and mimicked, well, they didn't mimic Google, they did their known filtered DNS and mimicked, said this is all 8's answering you, believe it. It also does session encryption, we've talked about that. Once you move into quick, HTTPS 3 or DOQ, you don't get conventional headed line blocking in TCP anymore. The queries can be threaded through, and faster answers can overtake slower answers, which is actually really useful, because once you're using this kind of streaming protocol, you get your benefit in both encryption and TCP. You get the payback in reusing that session again and again and again, so that you don't have to spend the session startup time for every single query. No UDP fragmentation, no TCP failover, none of that truncation issues, none of the time wasting that conventional DNS over UDP takes to figure out that A, the answer's too big, B, my UDP buffer size is all wrong, and C, some network in the middle hates fragmentation, i.e. V6. And so all of that just conveniently goes away. And as I pointed out, with TCP fast open, those long held sessions, particularly stub to recursive, then you amortize that relatively significant startup time, and even the TCP or quick session overhead times, you amortize that over the entirety of the stub resolver's query set, which means in the long haul, it's not much different to UDP in terms of per query overheads. Yes, if you do one query, then your server has about a third the load compared to UDP. That was a DNS OARC presentation from the Czech folk, I think, a couple of years back. But once you start reusing that session again and again and again, those overheads disappear, or at least become much less significant. So those are the general properties of DOT, DOQ, DOH. But why DO? And I picked this up from a couple of years ago from Paul Vixie in one of his presentations to NANOG. And you may be aware of this. He did it a few times around the world. And his view was, it's a political project, not a technical one. Quite frankly, if you can see the rest of the user's traffic, you know what DNS question they asked. And so, it's not really hiding what questions you're answering if you can see the rest of the traffic. And if you don't want to see you don't want your rest of your traffic seen, run up a VPN. And once you run up a VPN, everything's hidden. So what's your problem? And so he kind of saw this as a non-solution, and really just a little bit of enthusiasm on the part of the folk encrypting everything, going, well, you're not really hiding. And if you're just taking your DNS and hiding it, you're not really hiding. But I'm not sure. I normally find myself agreeing with much of what Paul says, but in this case, I'm not sure I'm on that side. One of the things the IETF did with DOT was to use a different port number. So it really did stand out like a sore thumb, going, wow, I'm using DNS over TLS because I'm using, a different port. Whereas with DOH, you're hiding inside TCP 443 or UDP 443 because it is HTTP traffic. It's not DNS over HTTP, it's actually DNS in HTTP 3 or 2. And so it's much harder to isolate that traffic. And indeed, there were some efforts to actually create a chameleon thing that detected that and changed its sort of identity so that you didn't use a dedicated server address to serve this, you just use the general server. You've also got another set of caching control, because generic HTTP caching is also applicable to DNS objects, because in this realm, DNS answers are just HTTP objects. And of course, HTTP2 and now HTTP3 does reordering, parallelism, priority, header compression, and all the rest of the tricks, which can be equally applied to DNS answers. And applications are not sending their queries through the local stub, the recursive, and so on. Applications now have choice. They can actually direct the DNS query over HTTP3 or 2 to the HTTP server of their choice. And last and not least, which is where we're heading, these protocols include server push. Here's RFC 7540, and HTTP3 allows a server to simply say, look, I know you're going to use this. Maybe it's a style sheet, but here it is. You haven't asked, but here it is, because you're likely going to use it. And because in this realm, DNS responses are HTTP objects, you can push them. A server can simply say, look, here's the answer. And in HTTP3, it's yet to be an RFC, but it's exactly the same thing. The words are subtly different, but quite frankly, you can push stuff. Why? Because it's faster. I'm not waiting for you to ask. I know you're going to ask. So here's the answer. Thank you. You're welcome. So when I send an HTTP request to a client, me as the server can also send through some DNS answers for the URLs on that page. They mightn't even be on the page. I can just simply send you DNS responses. And you've now got the answers. No query required. And so you can bypass all of those DNS resolution delays and go, here you are, here's an answer. You're welcome. You're not generating metadata. You're not raising your head above any parapet. The server is actually delivering that data directly without any particular reference to a question that you might have made. And Andrew's put in the RFC for quick. Thank you, Andrew. So it has speed benefit. And equally importantly, oddly enough, it has some privacy benefit that you're stopping, or at least the client is not making the query. The server's done it already, and it's simply forwarding the answer without the client makes no other active sort of query into the DNS. Sorry, that's 2 slides. How do you know it's the truth? I'm like, here's an answer. Great, but so what? It's just a server. The secure transport that I'm using means the server said it, and I'll believe that the server said it, but you really should validate that answer, because it could be complete arrant nonsense. And so unless you actually go through the validation dance, what you're being given for free is worth probably less than what you paid, nothing. So the user still has to chase down all of those DNSSEC validation queries, of which there are many, 2 per level in the hierarchy for the DNS key and DS records. And all of those speed advantages you were trying to get, blown away. So this is not good unless the server does more. Because if the server truly cared about you, and it really should, because why is it offering that DNS? Then it needs to also push all those validation responses directly. The server needs to say, here you are, here's an answer, and here's why you can believe it. Because unless you do that second bit, this is just junk. What about filtering done by the server, asks Michael Richardson for GenX domains? DNSSEC, Michael, DNSSEC. This means as long as you're sending DNSSEC, the answer is junk. Now, all those validation responses is a lot. You could repackage it, same data, but just package it into a single EDNS zero chain response, 7901. Why would you do that? I suppose just simpler packaging. It has no other benefit, but in some ways it's a neater solution. Here's the answer, and here's the chain of reasons why the answer is true. Single bundle, single object, single cache control inside HTTP. So I validate it as a client, which in the DNSSEC architecture, clients doing validation is completely unusual. Clients just simply look for the AD bit coming from the recursive resolver going, yay, this bit has been set in the clear. Therefore, someone else has validated. Yeah, right. Therefore, I'm going to believe it. You know, there are two English words that I kind of love. There's what is being credulous and credulity. They're wonderful words. And what they sort of describe is over-believing, naively believing everything that someone says, yeah, it's true. And quite frankly, clients believing the AD bit verges way over into credulity. If you really want to trust what you're seeing in the DNS, go validate yourself. Now, if you validate, it's authentic, it's current. As long as your RRC time values are compressed down a little bit, and they should be, it's the answer for now. And for each RR type, it's the entirety of that RR type. It's complete. So DNSSEC validation gives you, if you will, the three things it says, this is real data. And interestingly, if that's the case, it doesn't matter where you found that answer. If you can validate it, it doesn't matter if you picked it up in the gutter or you asked some authoritative server, you asked a random recursive, or some random server gave it to you. It doesn't matter. It's true. And so in some ways, DNSSEC validation is actually the key here. And even NX domain, though why you would push NX domain beats me with a stick, you can send the NSEC record if that's your bent. Validation is the key thing. And if that push DNS response is unsigned, it's rubbish. You have no idea where the server got it from. You don't know its currency. You don't know if anyone's deceiving you. If you use it, you really are out on a limb. Don't. And so if it's unsigned and there is no signatures, don't use it. It's a bad idea. So interestingly, Resolverless DNS actually has some really cute angles. I can pre-provision. And the best key to speed is to get rid of the query. Get rid of it completely. Have the client already armed with the data that they can use immediately. It actually allows the client and empowers the client to perform their own rapid validation, because all that's left for the client to do is actually the crypto. There's no stub resolver getting in the way, and you're not relying on the stub resolver's capabilities to do anything. You've got none of the UDP-based timers, the query retimers, the fragmentation, the truncation bits, TCP switching. None of that is there in Resolverless DNS. It's secured and it's with an authenticated server. I know who I'm talking to. And it doesn't leak metadata through the DNS. And so in some ways, all of the things that we've been trying to do in the last 10 years, all of those efforts to make the internet faster is actually a key part and contained in Resolverless DNS, as long as the data is signed. If it's unsigned, don't do it. Because if it's unsigned, you're just opening up more vulnerabilities and there's no mitigation, none whatsoever. You could actually argue there's no mitigation on unsigned DNS, no matter where it is. But server push, I didn't even ask anyone. Someone just gave me this answer. It's hardly a good reason to use it. If it's unsigned, it's not worth doing. So where's this leading? And it's oddly enough, not technology. It's actually leading into economics. Advertising-based content and services suck the revenue base from everyone else in our world. You know, people pushing packets are not rich. It's a commodity infrastructure. The DNS itself, the resolution infrastructure, even authoritative servers are not rich. No one inside this infrastructure space is making anywhere near the money that the content folk are making, the advertising funded content and service folk, because infrastructure is now boring. It's commodity based, and being commodity based, there is no innovation left because there's no money to do it. And so the incentives to actually change the world and to make it faster are up there in the application and service layers. HTTP3 is there for a reason, whereas our efforts to try and change down at the lower levels, new IP, name-based networking, all of those things to innovate right down at the lower levels of the stack, dead on arrival. There's no money left because there's no money there. Infrastructure is under constant pressure to simply do it for less, not more. Scale up, centralize, and reduce cost. Don't innovate. And the DNS, oddly enough, which straddles both upper and lower levels, is actually caught up in this. And trying to make changes in the DNS is really, really hard. And what we're seeing is, of course, the trailing edge of resolvers that keep on asking A6 queries and so on, still out there. Because, quite frankly, innovation only happens at the top levels. Everywhere else is actually a wasteland of commodity, of lack of investment, and just simply sweating the asset. And so if that's the case, does Resolverless DNS even have a chance? Are we willing to innovate even this much? And I would actually answer yes, but it's a package. DNSSEC comes along with it. And of course, that's a really, really hard ask, because although definitive answers are hard to find, I think the best way of describing it is very few zones are assigned with DNSSEC. 1%, 2%, whatever. Why? Because signing a zone is an absolute pain. The signatures get large, and all of a sudden, if you're using UDP, it's a nightmare. Very large zones, signing an entire zone is almost impossible. So then you need on-the-fly signers, and that can be fragile. .au managed to trip over itself and break its signed zone with an online signer that left a bit out. It left out the RRSIG for the zone's DNS key resource record. Oops. People don't like keys. They really don't. They're awfully lousy at handling it. And when you've got multiple DNS providers, sharing keys across multiple providers is also a nightmare, as we've been seeing. And so in some ways, DNSSEC is regarded as don't go there, you know, it's evil, unreliable, and you need to have a PhD in DNS in order to run it. And of course, producer consumer, who consumes it? Almost no one. Very few resolvers validate. Very few resolvers validate because it takes time. And as I said earlier, it stresses out DNS over UDP because large answers. And so it sort of seems maybe not. But what if rather than using the DNSSEC OK bit in the query, you actually look at 7901 and use the EDNS0 chain option and actually integrate that? If you want it, you want the entire set of validation answers, set the chain option in your query, and just get the lot in one bit all the way back to the client. So the client gets the DNS response and the chain of signatures, the client can validate. And if you set the EDNS0 chain option and the zone's unsigned, there's no DNS responses pushed at all, maybe. That's an interesting thought. Why is that an interesting thought? Well, in some ways, this is a way forward. Because if you look at the DNS as being a huge time penalty, a massive privacy leak, and a consistent source of insidious low-level failure that is the bane of everyone's help desk, then fixing this by pushing answers is actually an interesting way around the problem of just-in-time delivery, changing the paradigm to just in case. Now, this is not a panacea. This is not going to fix everything, nowhere near it. But it can handle control to the folk who want control. Most of the issues about pushing stuff up the stack is actually about giving applications and services control over that quality, control over the user experience, rather than relying on third parties, which is really the motivation behind a huge amount of the effort in the last 10 years to push things up into the application space, including Quick, which is a simple argument of actually having control in the application and not relying on the platform. Same story here. It's a whole lot faster, and it hides the client from the resolution infrastructure. So it has privacy reasons. And so for that, this is actually really interesting. And I'd actually argue it's actually what we've been doing over the last 10 years, because we've kind of said that physics sucks and moving packets around the globe is too slow. We're now using abundance in our infrastructure, particularly in bandwidth and storage and compute, to actually move content close to users. Most of your traffic in terms of packet miles runs a couple of miles. That's it. We've been doing all this work at the transport level, pushing it up from the kernel into the application space, Quick, and actually doing non-blocking transport and exploiting parallelism. We've been mucking around with BBR and network behavior. It's just faster. And now with SVC and SVCB and HTTPS records, we've been actually pushing the DNS to make service rendezvous and startup way faster. Oh, you need to follow this chain of queries to query this, to query this, to query this. With an HTTPS query, you give it the service name, the port and protocol, and you get back the answer. You get back the answer, even including the encryption bits to actually hide the SNI, all in one answer. It's faster. And if you look at where that innovation is happening, it's in the application level. It's not down at the lower levels. And at the application level, there's ample money. God knows there's ample money and a really impatient agenda. And at the lower levels, it's a wasteland of money. And there's certainly very, very patient people. There's no impatience to get things done. So it's interesting insofar as it matches the motivations of where the money is going in this industry. And for that reason, I think it shouldn't be dismissed. It actually is interesting. And if it's tied with DNSSEC, I think it's actually a valuable thing to do rather than an interesting quirk of protocols. So with that, I'll hand it back. But there is one question here from Jim Reed. Why rely on DNSSEC validation when no one knows or cares? Well, in some ways, the issue is if I want to push you an answer and I'm a server and you're a client, and it's going to be invisible to the user, invisible, then the only things I should push you are things that the client should or must validate. Because otherwise, I'm just pushing you random bits and you would be a fool to believe it. And so in some ways, there is no padlock. Resolverless DNS server push should only be with data that is validatable. And at that point, it's client beware. So with that, Andrew, I'll hand it back to you for questions. Thank you.
Thanks, Geoff, and thought-provoking as anticipated, which is marvellous. I'll throw a couple of sort of comments or questions your way, and then open up for questions, comments from others. So if you've got anything you want to come in with, either use the Zoom tool to raise your virtual hand, put something in the chat if you can't talk, or find another way to catch my attention if neither of those two are open to you. But two comments. Firstly, just reflecting on Doe, my personal view is I think that performance was the primary driver for developing Doe, and privacy was a useful side benefit, but absolutely not the reason why it was brought out. In terms of the application layer specifically. So picking up on Jim's point, in a way, I could see applications, sort of client software, I'm thinking browsers in particular, being tempted to go down this path, but quietly forgetting about the DNSSEC bit, because that's potentially messy, and when it goes wrong, it gives a bad user experience. So I could see them be tempted by the performance gains, not so much by DNSSEC in particular, which they've been pretty reluctant, certainly a number of the browser developers, to pursue. So first question, or comment really would be, yeah, I could see this happening, but not completely as you've described it, because the performance is attractive. But secondly, the other thought to maybe throw in is to do all this data push. Yeah, it gives me performance gains. What about the sustainability aspect? Because potentially I'm consuming compute cycles, I'm pushing packets that aren't necessarily needed. This feels like a lot of additional traffic, much of which could be jettisoned. So any thoughts on that? And then I'll see what other questions and comments people have.
I said we lived in a world of abundant computing, and we do. And most of the abundant computing is not in the core. It's in your phone. It's at the edge. There's an astonishing amount of compute capacity in the device. You know, these are it's black, so it doesn't come out. These are 1980s supercomputers. Yep. And asking them to do some crypto, the same as what they've already done to do the TLS session or to do the quick, is kind of trivial. So it's not the compute. The next thing is the reason why everyone hates DNSSEC, well, not the reason, one of many, is this unraveling of the validation chain. Incrementally, that is a showstopper. No one is willing to go check, check, check. And in fact, I did load up the TLSA validator into one of my browsers. Thank you, CZNIC. And, you know, at times you went to a page and just sat there and froze for 3 seconds while it did the check. Unacceptable. Just totally not going there. I think eDNS zero chain extensions 7901 is a game changer. It's a game changer for 2 reasons. It offloads validation to the other end. All of the work to get that validation information is done by somebody else in advance. And because it's Resolverless DNS, it's not even in real time. I can load up those DNSSEC validation answers and package them up in a chain and keep them there and serve them while they're current to the client. The client doesn't do anything. So there's no delay anymore. That's a win. And what's left for the client is I've got all the answers. I just need to do some crypto calculations. Do that, you know, lying on my back while watching virtual reality. It's not a problem. And so the reasons why we found DNSSEC hard, the whole UDP issue, the whole time delay issue, etc., actually get addressed in Resolverless DNS. And we also get back some privacy gains as well, because the client's not making any visible queries whatsoever. The server is making assumptions about what the client needs, but the client can just simply ignore them if it doesn't want to use it. But all of that stuff is now offloaded. And so the traditional reasons why folk didn't want to go there don't matter anymore. And this is what I'm arguing, that, you know, if you actually put these 2 bits together, chain extensions and Resolverless DNS, you actually come back with something that is A, useful, and B, really, really fast. And isn't that what we're after?
Yeah, fair comment. Okay, anyone else got any comments or questions based on what you heard? What do you think? Is this the direction of travel that's inevitable? Stunned silence. I'm astonished.
I know, I've either jumped on the rocket ship to Pluto and everyone's waving goodbye, or it's just completely logical.
No, this is completely logical, Geoff. This makes tons of sense on where things are going. If it was possible, you know, to reduce the queries to just those belonging to the domain, it'd be, you know, life would be easier. And I think that's one thing that's missing on your you need DNSSEC argument, is that you're going to get answers for queries from Google, from Facebook, whoever you're connecting to, that don't belong directly to them. And there's no way to tell that those are any better than the NX domain spoofed things that you get from your lousy local ISP. You know, there's nothing more trustable about them until you add DNSSEC. And I think that's the only thing that I would say needs a better explanation in your preset.
Okay, but yeah, I think this whole thing relies on DNSSEC. I think
I agree.
answers that I get for free is the same as crap I see in the gutter. If it's not DNSSEC signed, I have no reason to trust a server, because at least in the DNS, there's this theory in query-based DNS that if I ask the right address, I get the right answer, which, you know, we all know is still a bit stupid, but at least on the whole, I asked the right person, and the probability of getting wrong answers is much reduced. Whereas without DNSSEC, a server sending me random stuff, poof, you know, I have no idea, you know. And I think DNSSEC is actually key to making this useful. I would not do it otherwise. Yeah.
But you know all the pushback on DNSSEC better than I do.
Well, I do, but I think it's actually based around UDP, and it's based around iterative queries. I'm like, I too wouldn't sign a domain if iterative queries and large answers are part of the package. The only other thing that I heard about DNSSEC is actually a comment by Eric Rescorla that, oh, there's too much RSA 1024 in there. It's not very strong crypto. And that bit, I must admit, I reject. The one thing that DNSSEC has that the PKI doesn't is astonishing control over the time to live for crypto. In the PKI, I can take even 10, 15-year-old encrypted stuff and decrypt it, and it's still useful data. In DNSSEC, data vaporizes because once you exceed that time to live, there's no validation chain from the root to where you are, so you only need the crypto to live for basically the period of your TTLs. And so I would actually argue that RSA, even 1024, is not a bad thing as long as you don't use 10-year-long expiration dates in your RRCs. You know, as long as you don't create long-lived artifacts. And in the DNS, you know, some folk like their TTLs at 0. Look at Facebook. They had their TTLs down so low that they got locked out of their building before they could fix it. So, you know, keep your TTLs low, oddly enough, and you actually don't need, you know, RSA 4096. But even if you did, with Resolverless DNS, you're not running into the whole UDP wasteland, which really turns everyone off. I was actually wondering, you know, could I produce a domain that looks to be unsigned when I'm doing incremental UDP queries, but when I'm doing push or actually answering over a streaming protocol, I go, yeah, right, here is actually the reason why you should trust it, and only offer DNSSEC across streamed protocols. But I think that's stretching a bit far. I'm not sure you can do that by headed DNS that's only signed when you've got reliable transport.
That would be cool.
That would be cool, but yeah,
it would be cool.
I'm not sure how it could be done, but it is an interesting thought line, because that's the reason why people don't sign. They just look at DNS over UDP and go, nah, that's horrible. I don't hate my users. I really don't.
Geoff, do you know off the top of your head what the current sort of take up of DNSSEC is, or trajectory for it?
Okay, so, you know, there's two kinds of answers there, producers and consumers. Let me find at least one part of the answer, which we can measure, which is who validates. And in some ways, I think, in the early days of DNSSEC, we did the world a disfavor because all the browser vendors set the DNSSEC OK bit to on. And so even if you didn't ask for it, you got lengthy signatures attached to signed domains gratuitously, even if you didn't bother validating, which got everyone caught in this hell of you know, UDP overflow, etc. So let me very quickly share a screen here. This is the current DNSSEC validation rate for the world's user base. And so what that is saying is that the blue line is that around 1 in 3 users validate answers if validation is there, and that's the only resolvers they're using. So if it's a bad SIG, they don't get an answer because validation failed. The next line, 10%, is mixed. These folk have a combination of validating recursive resolvers and recursive resolvers that don't care. And so when the validating one says, so failed, they then go to the next resolver in acceptresolve.conf, which says, never mind, I'm going to give you the answer anyway. And in essence, around 40% of the world's users will try it. 10%, if they get a bad answer, go, nah, I didn't really mean it. Give me the answer. And 30% don't go there. So, you know, on the consumption side, there's an awful lot of brave people doing an awful lot of weird stuff in UDP. And, you know, they're living way out on the edge, I believe. But that is an awful lot of folk. But on the production side, Victor Duchovny's done work. I see various answers, and it's between, say, 1% and 7%. 7's a bit optimistic, but, you know, but I can understand why. UDP is hell. You know, there's just no point.
Excellent. Anyone else got any comments or questions that want to come in? Give you a moment to do so, or put something in the chat if you're somewhere where you can't easily talk. I'm not seeing any hands raised. I'm not seeing anything in the chat, so that's excellent. Well, let's close there. So, Geoff, that's really thought-provoking as always. So, thank you for that, and special thanks for getting up at such an early hour, which is also much appreciated. Hopefully, it's not as wet in Sydney as it was during Osnog, and you're getting a reasonable autumn now with a bit of sunshine.
I think continental drift has moved the continent just butting down to the South Pole in the last week.
Oh,
yes, I hate winter.
Well, look, I'll just do a couple of things briefly. So you're very welcome to stay on or disappear, go back to sleep as you prefer. But thank you, much appreciated for doing that.
Thanks, Andrew.
Right, and then just very briefly do this, mindful of the time. So just to quickly highlight a couple of things from the last week or so, which are in the sort of weekly headlines email. Oh, I didn't mean to do that. Let me just go back. So there's an interesting article by Ericsson, just to sort of giving some thoughts on the use of private relay mask and PPM amongst other things. Has been, you know, suggesting that's really the direction of travel for privacy, which is worth a read, as is an article revitalizing global internet governance, for those of you interested in such matters. And I mentioned already, but I'll just remind you, so the early bird rate for ITF 114 expires at 23:59 UTC today. So if you haven't pre-registered yet and going to do so, you'll save you $175 by doing it today rather than tomorrow on UTC time, so you're aware. There's a whole bunch of events this week. NANOG, RSA, WWDC, of course, and also on Thursday this week, Mozilla running what looks like an interesting event, building blocks for a trusted internet. So a good choice of things this week, a very popular week for running events. And then finally from me, reminder that next week, Steve Stadden from DNS Filter is coming on to talk about protective DNS, DNS encryption, and zero trust. And I'm tentatively looking to the 27th June for a panel discussion, just really continuing the panel discussion we did from a few weeks back, which seemed very, very popular, but with some additional sort of different participants, just looking at the sort of learnings from the deployment and scaling of encrypted DNS resolvers. I'm trying to get some additional resolver operators to share their experiences, as well as some software companies as well. So as soon as they come back to confirm their availability, I'll firm up on that, but tentatively we'll do that on 27th of June, subject to availability of people. So that's it from me with a minute to go. So I'll just check, does anyone else have anything that you would like to raise before I wrap up the call? And if so, just jump on, unmute and say so, otherwise we'll wind up there. Right, I'm not seeing any signal anyone does, so let's call it a day there. So hopefully you got plenty of food for thought from Geoff to go away and ponder. So thanks again, Geoff, for doing that. Have a fantastic week, everyone, and look forward to seeing you on the call with Steve next week, as I just mentioned. So enjoy the week, everyone. See you next Monday, but back at the usual time, 1500 UTC. Bye all.